Go ahead, Marty.
This is November 13th, 3 days till the end of hunting season. And this is the math class. We're going to be learning something new today. Percentile tiles.
Wonderful, Martin. Thank you.
Is that it? Say exactly.
That's it, percentile. So, in our previous class, we did mean deviation. Mean deviation took a whole big list of numbers, and we figured out, on average, how far away those numbers are from the mean. So we wanted to know how closely grouped our data was. Percentile allows us to rank data. So you've actually done something similar to this before when you did your quartiles. When you did quartiles, you divided your data up into 4 equal chunks, each with 25% of the data. Percentile does something similar, but it divides the data basically up into 100 different chunks, 100%, and you can use that to rank. Okay? So a percentile is a number given as a percentage, and this is what it means. For example, if you are in the 55th percentile, so 55th percentile means that 55% of people or data or whatever we're looking at, so I'm going to just say of the data, are equal to or below that piece of data, that number. So you'd have a number and you'd say, okay, that number is in the 55th percentile, 55% of people or data points are below or equal to that number. So if we make it an example and we say your mark is in the 60th percentile, your mark of 70%, okay, your mark of 70 is in the 65th percentile. So if your mark is in the 65th percentile, it means that 65% of the people got either the same mark as you or a mark that's lower than you. And so I don't know where my text went. Okay, so let's look at an example. How do we actually go about calculating a percentile? All right. So the formula for percentile equals number of data less than x, so less than the number that you're dealing with. I'm going to have to make this smaller. So percentage of data, or number of data less than x, plus number of data equal to x divided by 2, all divided by total number of data and so just the number equal to x, all times 100. Okay, so percentile is equal to the number of data less than x plus the number of data equal to x divided by 2 the whole thing divided by the total number of data times 100. Okay. Here is big thing. Very important note. We always round percentile up. Always round percentile up. Okay? So even if your answer is 12.03, you round up to 13. We always round percentile up. This is something that has cost people 4 marks on the final exam time and time again, because there's often either a multiple choice or a short answer question that just is very simple. It says calculate the percentile of this. All right? If you have this formula, you just gave yourself 4, because the 4 marks is 4% on your final exam. And if you forget to round up, you get the wrong answer. I can't give you anything. You get 0. And because they're kind of mean, they almost always make the situation where you get 12.1 as your answer. So your instinct would be to round down, and they're testing to see if you know that you always round up. So just keep that in mind, all right?
So the answer is 12.1?
So the answer, 12.1 would be 13. We'll do an example here so you can see what it looks like.
You can't round up if it's 12.1.
You always round up for percentile. That's the point that I'm making here.
But you can't, sir.
You have to.
It's the rule.
It's not your regular rounding rules. Percentile, you always round up to the highest integer, or to the next integer.
Okay.
Okay? You alright with that?
Yeah, I'm good.
Okay. So here's an example. So for example, we have these numbers. 1, 1, 3, 5, 7, 7, 12, 15, 43, 90. Okay, what my numbers are actually is makes no real difference because we're not calculating mean, median, mode, anything here, we're just calculating percentile. So, the question is just going to be find the percentile, or percentile rank is often what it's called, for 7. Okay, so find the percentile. I'll leave my formula showing for 7. So if we look, when we're doing this question, we've got the 2 7s right there, so those are what we're going to deal with. Alright, let's look at our formula. So I shorten this up. I write percentile, not percentile, percentile equals, and I write it just as this. I write number less plus number equal over 2 all over total number all times 100. Just makes it a little bit more compact, a little easier to fit into one spot. So let's look at our example. How many numbers do I have that are less than 7? 4. 1, 2, 3, 4. So number less is 4 plus. How many do I have that are equal to 7?
1. 2.
Okay, the right answer is 2. There's one other one, but you're just looking at how many 7s do I have. Okay, so there are 2 7s. 2 divided by 2. All going to be divided by how many of my total numbers? How many total numbers do I have?
10.
Is there 10, really?
Yeah.
Cool. Did that by accident. Divided by 10. All times 100. So, if we're showing all of our work, 4 plus 2 divided by 2 is 1 over 10 times 100. 4 plus 1 is 5 over 10 times 100, which is going to equal 50. So your 50th percentile. Okay. That was just a really simple, basic example. Came out to a nice round number. I will warn you that 99.9% of the time it does not come out to a nice round number. You're often dealing with way more than 10 numbers as well. You're often dealing with hundreds of numbers.
Whoa!
But the good news is that you don't have to do anything with those hundreds of numbers. It's not like you have to add them all up and divide by however many. You're just counting. You just count how many are less, count how many are equal. That's all you need. Okay, so we'll do another example here in a second. Is everybody okay with how that looks? Pretty straightforward, not too difficult. Okay. Can I move it? Okay. So here's how your examples will often look in the textbook. Okay. Example 2. They'll do this. They'll show 1, 1, 2, 4. Okay. And then they'll go dot, dot, dot. Then they'll go 20, 24, 27, 30, 30, 31, 32, and then they'll go dot, 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 and then they'll say 60, 62. Okay? And they'll go over here and they'll say there's 40 numbers here. And they'll go over here and they'll say there are 57 numbers here. Okay? So instead of writing out all of those numbers, they gave you a chunk at the beginning, they gave you the middle chunk, they gave you the end chunk, and they said, oh yeah, there's a whole bunch of numbers in here. Okay? It's just laziness on their part. And it makes it easier for you because you don't have to add up a whole bunch of things. What I want you to do is, for this one, find the percentile for a score, we'll call these scores, we're not really sure what they are, of 31. Okay? So you'll find 31. There he is right there, all by his lonesome. Okay, and we're going to use that.
31?
31, yeah. So, we'll write our formula. Percentile equals number less plus number equal over 2 divided by total number times 100. And we'll fill it in. So number less. Okay? 49. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, plus the extra 40 numbers there. So we have 49 numbers less. Plus. How many do I have equal to? Okay? 1. And this, so that's fine because you're right. There's only 1 there. So you have no others that are equal to it. But for the purpose of doing percentile, number equal might as well be how many of that number are there. Okay? So if you want to make a little note in your notes that kind of circles that and says how many are there, that might be good for you. So it depends. I understand the confusion. Some people like number equal, some people don't. So it's how many are there? There's 1 of them. So 1 over 2 divided by my total number. Okay? So I had 49 that were less than or equal to. 49 that were less than. So 50, 51, 52, 53, plus another 57. It's going to equal 110. So there's 110 total numbers. All times 100. So this equals 49.5 over 110 times 100. Someone with a calculator. Actually, I have one right here. So, we shall do 49.5 divided by 110. That equals 0.45 times 100. That equals 45. So therefore, the number 31 is in the 45th percentile. Okay. Again, very important, if you get a decimal answer here, you always round up.
Are the numbers in the examples, would they have decimals in them too, or not?
They could. There's no reason why they wouldn't. But these numbers really mean nothing to us, right, Garth?
Yeah.
Because we don't have to do any work with them.
Oh.
So a good example would be if you were looking at race times. There's going to be decimals. They're time. Okay. Now, that race times brings up a good example for me. So what's that, Marty?
In the 40.
45th percentile. Race times brings up a good example for me, or a good thing to think about. Okay. This question here, this formula says number less. But really, what it could or should say is number worse than. Okay. So if you're dealing with a race, and you finish 4th in that race out of 10 people, well, you'll have three times that are less than yours. But those 3 times are actually the people who beat you. Okay? So you really have to think about the example. When it says number less, it might as well be number less than. Alright, we now return from our regular scheduled program. So far you've calculated percentile. It's also possible to calculate the opposite direction. So if you're given a percentile, you can figure out what number that percentile corresponds to. So we call that calculating position. It's important, as you'll see in a second, that you're calculating the position, not the value directly. So when you calculate position, you're finding out where the 15th percentile happens, for example. But you're not figuring out what that number is. You have to then look at your data to figure out what that number is. Okay? So, calculating position works like this. The position equals percentile over 100 times total number of values.
So it's basically the same formula, but
It's just the backwards of it.
opposite.
So it's a little bit, it's the reverse. You could figure out one from the other. Okay? This is going to tell you where that value happens. So, for example, what's the best way to do this? Let's do this. We have these numbers. Okay? And they could ask you which number corresponds to the 27th percentile. Percentile question. Okay, which number corresponds to 27th percentile? So whenever they're asking you for the number rather than for the percentile rank, you can use the position formula. So I would say position equals percentile 27 over 100 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. I forgot to add one very important note, so you're going to have to put a little star beside position. Okay. For percentile, we always rounded up to the nearest integer, to the nearest full number. For position, always round down. Okay, very important. That's why I put 3 exclamation marks. Okay, percentile, you always round up. Position, always round down. Just make sure it's on your memory aid, very clearly indicated. Percentile, here's how you do it, always round up. Position, here's how you do it, always round down. And you won't make any mistakes that cost you very valuable percentage marks. So if we do this, 27 divided by 100 is 0.27 times 13. That equals 3.51. So therefore, it's the third, look how this worked out, position. That doesn't actually answer my question though.
Okay, good.
Okay? Because it tells you where it is. It's the third number. Okay? But it doesn't tell you what the number actually is. And I laughed and I said, uh-oh, look how this worked out. If we actually count 1, 2, 3, the third number is actually 3. Totally coincidence here. Alright? The position does not always equal the number that's there. So if we calculated, we'll do another example just so I can show you what I mean. And leave this number, and we're just going to say calculate. Oops, I don't want red. So calculate the 75th. Or not calculate the 75th percentile. Calculate the number that corresponds to the 75th percentile.
Can I put matches instead of corresponds?
Sure. Okay, so again, we're going to use the position formula. Position equals, in this case, it's 75 over 100 times 13. Okay, if I do that calculation, I get 9.75. 9.75, so therefore it's the 9th position.
Why do you do those 3 dots before
It means therefore. Okay, and therefore this is the 9th position. If we count it out, 1, 2, 3, 4, 5, 6, 7, 8, 9. So our answer is 12. Okay, 12 is the number. That would be the 75th percentile for this data. Okay. So you can see the first time it was the same number, but it's not always the same number. Okay.